let's get started. We are going to talk about network security fundamentals. We are being introduced to network security concept, and we will be expanding on them in the second module, routing, switching, and wireless essentials. And we will also talk about it a little bit in the third module, enterprise networking, security, and automation. And so for network security fundamentals, basically what we are going to talk about, we'll explain why basic security measures are necessary on network devices. We will identify security vulnerabilities, which are basically security weaknesses in a system or a device, general ways of mitigating those vulnerabilities. And finally, we are going to learn how to configure network devices with some device hardening features to mitigate security threats. And it's important. One of those things we'll talk about is SSH. And so we learn how to configure both routers and switches with this security enhancement. And so to start us off, we have what is called threats and vulnerabilities. So it's important to note that these attacks can be very disturbing. They can be very devastating, the word we used here, because it leads to so many bad things. People lose money in mitigating against these attacks. People lose time in trying to regain themselves. People lose even their own image. Okay, they damage their reputation, and sometimes they lose some information due to information theft, and even some of the assets can be lost. And these threats can actually affect our network because of things we can prevent. Things like some weaknesses in software that is not up to date, or software that needs to be updated. It can be hardware attacks. Okay, it can be hardware attacks. Maybe you haven't configured that password well, and in such a manner that someone can easily guess it, or it's a username. And so the people who carry out these attacks, they are actually called hackers, but we also call them threat actors. They take advantage of these weaknesses we have in the software, and that can lead to so many of those things that I've talked about. And sometimes they can even disrupt the services within our network. They can always disrupt the services within our network. And so it's important to look at what are some of the types of vulnerabilities. And we first start by defining what a vulnerability is. So a vulnerability basically is some kind of weakness, some degree of weakness in your network or on a device. Okay. And these degrees of weaknesses or vulnerabilities, it can be in your laptops, in your desktop computers, switches and routers. It can be on your servers and even your firewalls. It's important to note that any device can be vulnerable. And so the most commonly attacked network devices are basically endpoints. Endpoints are the end devices, laptops, tablets, mobile phones, desktop computers, printers, servers. Those are under very serious attacks. And to categorize these vulnerabilities, we can do so in three ways. One is technological vulnerabilities. So these technological vulnerabilities basically include weaknesses within the TCP/IP protocol. And that can include things like the operating system weaknesses or the equipment, a weakness in your system during the manufacture. That is a TCP/IP. That's, a technological vulnerability. How it is made, what is the version? Is this version stronger than the other version? Something like that. Then we have configuration vulnerabilities. Basically, this has something to do with configuration. That is what we are studying in this class. We're learning how to configure our devices, configuring our accounts, configure passwords, which we have, some of which we have learned, configuring services. And we are running away from configuring devices with poor passwords or misconfiguring them using protocols like SSH and not Telnet. Very, very important. So those are vulnerabilities at the level of configuration. Then we also have vulnerabilities at the level of security policies. Every organization must have a security policy. Policy, by the way, this is just a document which outlines the security policies that everyone must adhere to within the organization. Every organization must have a written policy. And the lack of these policies can be very detrimental to an organization. And it can be, you've seen some organizations, you cannot install any softwares in their computers. You cannot even uninstall. You cannot do other things, that you're not permitted to do. You cannot even copy software from that computer. Everywhere you go, they need password. So policies are also very important. So these always work together. All these three work together because they can put your network devices at risk. They can always put your network devices at risk. Let's talk about what is called physical security. So when you talk about physical security, we're actually talking about security that can deny a user physical access to a device. And this can actually pose a challenge, okay? Security that can pose a challenge to the physical devices themselves. And this can include things like damage to your devices. A device falls down or someone hits it very hardly, or, or it's burnt or someone steals it. So hardware threats, very, very important. We have those threats that are caused by the environment, when it is too hot or too humid or too, dusty or something like that. So because of the environment, again, this can cause environmental threats. For electrical threats, this ones includes, the variations in power supply to your electrical equipment or to your networking devices. Okay, can include things like voltage spikes. Voltage come in a very high voltage. I mean, power comes in a very high voltage. Sometimes it comes in a sufficient, and we call that brownouts. Sometimes, it comes as noise when it is not conditioned. It keeps on changing from high to low, low to high, and that can cause a problem. Sometimes it's just total blackout. We call it total power loss. It's completely gone. Then we have maintenance threats. This is as a result of handling of your devices. Do you dust them? Do you keep your cabling well? How do you handle your devices? The cabling, are they just everywhere so that people can step on the cables? Do you replace spare parts that are worn out? So this is very, very important, again, as far as physical security is concerned. For network attacks, we now talk about 3 types of malware. And you know what malware means in full? Malware means malicious software. Malware means malicious software. So, and the word malicious, of course, can be harmful, something like that. So it's just a piece of software or code designed to cause some bad ills, like it can damage, it can disrupt. Sometimes it steals information, or it causes some things like, your computer keeps on going on and off. So those are, some bad reputations of malicious software. 3 types of malwares that we have, or malicious softwares. We have viruses, worms, and Trojan horses. Of course, we'll talk about many more, but we have viruses, worms, Trojan horses. A virus, basically, like we hear about the coronavirus. A virus is a type of malware that, it propagates itself by inserting a copy in itself. Think of the coronavirus. Someone can pick it up, then as someone picks it up, it can keep on spreading from one person to another. So it's important that viruses which are motivated by human activity to spread from one person or to propagate from one device to the next. Use a flash drive, plug it where there's a virus, it can spread it to other computers. Worms, they have some similarity with the viruses, but worms are basically standalone software. They don't require a host program or any kind of human help to move from one device to the other. Okay, because worms move over the network normally. They're not motivated by human activity to move. And the last one is Trojan horse. The Trojan horse is this is a very harmful piece of software. Normally it looks very real, it looks very legitimate. Okay, and they normally they don't reproduce by infecting other files or other devices. So they can be transmitted through maybe emails, attachments, or downloading a file from the internet. So it downloads together with it. So it's important, I think, for us to get to know this and to note these three types of malware: viruses, worms, and Trojan horse. Now, in terms of attacks, this word reconnaissance is a very important word. And the word reconnaissance simply means information gathering attack. Because this is a kind of attack which gives the attacker or the threat actor the magnitude to collect information using different utilities. They can do NS lookup on the CMD to get the IP address of different servers. They can use Whois, is another website. They can just checking the IP address of different devices. They can even ping them and use traceroute to get as much information as possible. So it's a discovery and mapping kind of attack. So the mapper, they get the details of each and every device on the network. Of course, we look at access attacks. For access attacks, basically, is having unauthorized access to some device or data and bypassing some privileges that are available there. It is an authorized attack. Then denial of service attack. Denial of service is when you disrupt services to genuine users or devices. It is completely disrupt services to for people that are very genuine within the network. Some of the access attacks, of course, include password attacks. It can be password hacking, password cracking attacks. A very good example can be brute force. In brute force, you keep on guessing someone's password until you get it using different password combinations. Then we have trust exploitation attacks. Here, the threat actor normally uses unauthorized privileges to gain access to a system. So a system might be easily accessed using SSH, okay, using SSH, but there are other devices there that can be accessed using Telnet, because those two are same protocol, but one is secure, one is not secure. So the device you have trust with, you can use the secure version and then use the insecure version to be able to know more about them. There's those that port redirection, which also uses the different ports. We did learn about some ports the other day. We talked about SSH is port 22, Telnet is 23, HTTP is port 80, 53 is DNS, 20 and 21, obviously it's FTP. So the threat actor uses a compromised system to attack a system that is not compromised once they are inside the system using different port numbers. And SSH and Telnet is also another very good example here. Man in the middle attack, two people who are communicating through the network, the threat actor can position himself between the two actors, and they can either copy information or there's basically they come in between the two people communicating, and they can do so many things. They can copy the communications you people are relaying. They can even modify the communication relay. Very, very important. So those are those attacks. So for denial of service attacks, of course, we'll be talking about this soon enough. We will be having a demonstration of the same when you get to the second module. This is one of the most sophisticated attack because it's very difficult to prevent or to eliminate, okay? Because normally there are two versions of it. We have the denial of service, which is DOS or DOS, and then we have the distributed denial of service attack. So the distributed one is an attack that, it's a multiple DOS attacks. The distributed, the denial of service attack comes from one particular device or one particular hacker. But the distributed one, it's now coordinated and it comes from multiple sources. It comes from multiple sources. And that's what makes it to be extremely difficult to prevent. Extremely difficult to prevent. Very, very important as a protocol. And so it's important that some of these attacks, we pay keen attention to them because they are the most common. They are most common within our network. Now, so looking at some of these attacks, all these attacks must be protected in a way. And I want you guys to know that security is not a one-man show. And security is not a one-device show. And you cannot have, but now this is the criteria for putting up security. It's everyone's responsibility, and it is something that requires so many devices. And that's why we have what is called the defense in-depth approach. In defense in-depth approach, you protect different gadgets at different layers, okay? Which is the defense in-depth approach, also called a layered approach, okay? Because it requires a combination of different network devices and services which work together to provide security. So a network can have virtual private networks, VPNs. A network can work firewall, the ASA, the Advanced Security Appliance firewall. It can have what's called an IPS. An IPS is an intrusion prevention system. It can also have what's called ESA or WSA, where ESA means email security appliance and WSA means web security appliance. So from the word email security appliance, clearly that filters email traffic. Web security appliance filters web traffic from the web servers. Very important, so that the two of them are separated. Of course, we have AAA server there. Here's authentication, authorization, and accounting, and that is just the other security. So in most defense in-depth securities, they'll have a multiple of this, and they'll even have more. They'll have things like access control lists, which basically those are statements you configure within the router to be able to provide security. Now, as part and parcel of security, always feel important, please, to be backing up your data. You must back up your data and configurations. Very, very important. Because if you don't back up, you wouldn't have a failover for you. So check on the frequency of backing up your data. Is it going to happen monthly or weekly? Where are you storing them? You must have enough storage It is validated. Are they secure? And then you need to validate your storage with strong passwords. Okay, so that is important. Apart from backing up, you need to upgrade, update, and even patch. So upgrade basically means you move from, like, for example, one operating system to another operating system. You have upgrading. Updating, it's making a piece of software by installing small pieces of code to make a software work more efficiently. But patching is now sealing security loopholes. Piece of code which fixes security features within your software. So there's updating and there's patching. You must get the difference. Updating, you install a piece of software to make the software to be more efficient. But patching, you patch a software that looks vulnerable, okay, or that has some zero-day attacks. Then we have the AAA server, where AAA means authentication, authorization, and accounting. So always call AAA. This is basically a network, a group of network services which always work together to perform the same function. Okay. So let me give you a very good example. Is when you go to the bank ATM lobby. When you go to the bank ATM lobby, the first thing you need to do is that you need to insert your ATM card. Insert the ATM card within the ATM machine. So when you do that, the first thing it does is that it requires you to put a pin. It requires you to put a pin. So what the pin is doing is if you put the correct pin, that's how the bank proves you who you say you are. So that is called authentication. You are being authenticated by the system. Once you put the correct pin and you let in, now everything that happens there, there are things you can be allowed to do and the things you'll not be allowed to do. For example, you'll be allowed to withdraw some cash, but you cannot withdraw more than what you have in your account. You cannot withdraw from someone else's account. Okay. You cannot withdraw coins within ATM. And those are very key terms there. So once you are authenticated, you can only do what you are authorized to do. That's authorization. What are you able to do once you are in the system? And what are you not authorized to do? Okay. Then once you have been authorized to do some things there and not others, everything you have been able to do will be kept in some records. Okay. The time you access the system, how much money did you withdraw? What is the balance? Yeah, I think that's it. So everything that has been done must be accounted for. That is accounting. So authentication, authorization, accounting. M-Pesa uses this a lot to authenticate a large group of people. We use this, and we'll study it in wireless networks. When we'll be studying about the WLAN, we look at, for a wireless network that accommodates so many people, we always need to use AAA. Talking about firewalls, we have different types of firewalls. We have application filtering firewalls. This one's filter based on whether it's IP or MAC addresses of the packets. Application filtering. This is prevents access by specific applications. So at the level applications or specified port numbers. And the URL filtering, of course, uses URL. Any uniform resource locator that are being passed across the firewall will be blocked or permitted. So, of course, we have the stateful packet inspection firewalls, SPI. This does a very serious background check, and you can always filter out or prevent some attacks like denial of service attack, stateful packet inspection. It goes deeper to inspect firewalls that are available there. Now, we have what is called endpoint security, and this is the biggest problem for every network administrator. How can we protect the end devices, the laptops, the computers, desktop computers? So every administrator, his most challenging job involves protecting the end devices, because the end devices are the closest to human beings. And human beings can be very funny sometimes. And so they've tried to use antivirus softwares and some intrusion prevention softwares. It's never enough. It's never enough. And that's why today we want to configure features that can help protect our network and even end users. Of course, Cisco comes with something we call Cisco Auto Secure, but we can never depend so much on the Cisco Auto Secure. So it's important that things like default names and passwords should always be changed immediately, should never be used. Accessing to system resources should be restricted to only people who are authorized within the organization. Okay. Any services or applications that are not running should always be turned off. It's important. Okay. And so to do that, we talk about passwords first. These are the policies for creating strong passwords. Every password must be at least 8, but we prefer 10 characters, 10 and above. Passwords should be complex. They must be very complex. They can include, upper and lowercase numbers, special characters, symbols, numbers, spaces, if they're allowed, that is. Then, apart from that, make sure that you avoid using passwords based on some repetition criteria. Avoid dictionary passwords. These are dictionary passwords. These are passwords that are from words in the dictionary, or number or letter sequences 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, very bad. You don't use any patterns when creating a password. Very, very important. Some people like using their pet names, their relative names, their biographical information, birth dates, ID numbers as password. Please avoid those things. Sometimes you can deliberately misspell a password. Instead of saying security, for example, the S can be a 5, maybe E can be a 3, maybe I can be an R or 1, TY, so on and so forth. Then please change your password so often. That's very important. Then don't always write your passwords in yellow stick and put it at the back of your desktop or back of your laptop or the bottom of your keyboard in the office. Please don't do that. Now, it's important to note that password policies are very important. And today we are going to add a few policies here. We'll see if we can be able to configure them. Of course, I know that we have talked about just a minute. We have talked about this one, service password -encryption. Okay, that is used for encrypting all the plain text passwords. We've talked about line VTY, password, Cisco. I talked to you about transport input SSH. But we also have this one here, exec-timeout. What is it used for? When you are logged in, when you are accessing the device remotely, okay, maybe using SSH or Telnet, we want that when you leave your computer unattended or idle for some time, we want it to log out automatically so that someone cannot come when you're not there and continue viewing the details of your system or configuring something or even configuring a new password. So you say exec-timeout, put minutes and seconds like this. So in the next 5 minutes and 30 seconds, the device will time out automatically and someone is required to put a password before they can get in. Then this is a bit longer. There's a new command here, which says login block -4 120 attempts 3 within 60. Now, if you want to know how this is used, one, have you ever noted some websites that you put a password thrice or 4 times? It requires you see a countdown that wait for 1 minute or 60 seconds before you can try logging in again. So this is what actually happens. So this command is saying block someone for 2 minutes or 20 seconds if they make 3 unsuccessful attempts within a period of 60 seconds. Okay, so login, block someone for 120 seconds within a period of 3 unsuccessful attempts within a period of 1 minute. Yeah, so login, block -4 120 attempts is 3 within 60. Within 60. Yeah, of course the rest is just saving over there. We will configure some of them. The last one is talk about SSH.
Just a minute.
Okay.
Kindly, can you go back to the? What about? Oh, okay. I've seen.
Okay.
I wanted to ask about the second one, but it's self-explanatory.
Which one? Which second one?
The security password minimum length 8.
Oh, sorry. I can actually talk about it here. It just talks about the minimum length that anyone who is configuring this router, they should never use any passwords that are less than. So you can put that policy. Any person configuring this device should never create simple passwords less than 7 characters. So it says security password min-length. So what is the minimum length of a password that can be configured for this device? So thank you for that reminder. Yeah, thank you for that reminder. I can also mention something here. Transport input, yes, transport input SSH. You're welcome. When you say transport input SSH, what we are trying to do is that we are trying to minimize such that only SSH should be used to access this device. Because you could as well say transport input telnet, so that SSH cannot be used on telnet. And you can even put both of them. You can say transport input SSH telnet. So, but we will be using this one. And I think today we'll also interact with, just taking you through how is SSH configured. And I'll give you some practice, for you also to do that. Now, I want you to note how to configure SSH. Very, very important. How do we configure SSH? And this one, I think, let me just bring up a packet tracers activity here so that I can put the commands as you see, and you'll be able to mark, these commands here. Yeah, my packet tracer is here. So let me bring up a router here. Maybe I can pick up 43, 41 here. So it's on. Okay, so my router is just powering on here, and I can also bring a PC here. Oh, let me grab a laptop here. Hmm. Yeah. Okay. But let me just leave that. Okay. So put a console there. Console put there. Every time you're asked yes or no, you answer with no or n. Very, very important there. But when you're asked yes only, you answer with yes. You'll never have no only. So what I want to do is using the instructions there to teach. Yeah. So this is my router. Can give it a name. Can say en for enable, conft for configure terminal. Let's say first name is R1. So configure the device host name. We have done that. Configure the domain name. So to configure the domain name of this router, we say IP domain hyphen name, and we can say cisco.com. .com is the domain name. Enter. So that is the first and the second step here. Obviously, the device will always have a host name, normal host name, which is just R1. So what is always lacking is the domain name. This domain name is very important for SSH to work. SSH cannot work without that domain name. Must. So once we configure the domain name, which is cisco.com, we can now generate the encryption keys. Why are we doing that? The encryption keys are actually used by this device to encrypt all the traffic. Remember, SSH, which means secure shell, is a protocol that is used to remotely access our device, which means the device is in Kisumu, you are in Nairobi, you need to access the device and check out what is wrong with it. So I will show you how to access it from the PC, what you will put on your computer in Nairobi here to access that device. So, I configure that domain name. Then I need to configure, I generate the encryption keys now to encrypt all my traffic. I say crypto key generate RSA. This command, you can actually stop there by just saying crypto key generate RSA. You can stop there. When you press enter, it will require you to put how many keys do you want to generate. The most common one is always 10, 24. Okay, the most common one is always 10, 24. You press enter and you generate those keys. You can still, there's a long version of this command. You say crypto key generate RSA general hyphen keys modulus. Modulus. So you say crypto key generate RSA general keys modulus, then you put 10, 24. So here you put everything on the same line. The first step, when you reach RSA, you press enter, then you put 10, 24. So you choose whatever. All of them are actually okay. This number you're putting 10, 24 are the number of keys that you want to generate, but the number can range from 360 all the way to 2048. But the most commonly used is always 10, 24. Okay, so press enter. And then I need to, when we say right now, show IP SSH, you can see we are currently using which version? Version 1.99. But you need to configure second version or version 2 of SSH. You just say IP SSH version 2. IP SSH version 2. And we say now show IP SSH. You realize now you're using version what? Version 2. It's no longer version 1. So IP SSH version 2 is the command to change it to that level. There are other configurations for SSH, but I'm giving you the basic ones for now. So we did what? We first created the domain name, IP domain hyphen name, put the name, Secondly, we generated the keys. And then now we have configured the version to version 2. Okay. Then we now want to create something very important. We realize sometimes within the IT department, we can always have 3 people or 4 people or 5 people. So what we want, we can actually configure for each person his own credentials for logging into this device. And so we create some account within the database. Okay. We create a local database entry for each and every user. How do you do that? We say username. Let's say the senior most person is admin 1. Okay. We say secret. No. We say this is optional but very important. That's why I'm teaching it to you. Privilege. The highest privilege is 15, and the lowest, you can even see it here. Privileges range from 0 to 15. The lowest privilege is 0. So the person with the privilege 15 has more rights than the person in privilege 0. So we give this person privilege 15, and then you say secret. Secret is actually the password. Username admin man, privilege 15. Secret is now the password. You can say admin 1 per 55. That is the password. Admin 1 per 55. So this is our first user. This is the senior most person within the office. Okay. We can create, let's say there are 2. We can just create another one. You say again, username admin 2. Privilege maybe 0. Secret, you say admin 2 per 55. Okay. That's very important. So we have created, and we can create as many databases as possible. That's actually okay. Then we now get to line VTY. You say line VTY, maybe 0 to 4. Remember what I said about 0 4 or 0 to 15? When you say 0 to 4, it means only 5 people can access this device concurrently. When you put a larger one, 0 to 15, say up to a total of 16 people can access the device remotely concurrently. So 0 to 4, then you say now that command transport input SSH. So you do that. You can still say, let me say, you can put transport input SSH, or you can say transport input telnet and SSH, or transport input all, or transport input none. What I've done is I've just pressed shift and question mark to see all the other options we have. So because you are configuring SSH only, you say transport input SSH and press enter. Now, if you want anyone logging into your device, remember in telnet and in even line console, we were saying password Cisco login. So here we want people to log in using the details we have in our database, the local database we have created of usernames and passwords. So we say transport input. Sorry, we are repeating that. You say login local. You say login local. Very important. Login local. And you press enter. Login local. All right. So transport input SSH, login local. So those are very, very important information that we have there. And that's it for configuring SSH. Okay. Let the domain name be there. Generate the keys. Create the database. And then authenticate the data using line VTY to enable users to get in. And that's it. We're going to do another example. where you shall be able to see that eventually happen.
Maybe just a question.
Yeah.
About the privileges.
Okay.
When you give a user 0, to what extent are they
Yes.
able to access maybe the system?
All right. All right. All right. Okay. Let me demonstrate that. Let me demonstrate that to you right away. I think I forgot to actually do that. So I need to know which interface had I used there. Let me just zoom this a bit. I want to show you that just right now. So I wanted to know which interface is connected here. Let me just see which interface had I configured this one on. So Z. So show IP interface brief. Show IP interface brief. So I'm having interface G00, interface G01. If you can remember very well, I want to know which one is currently connected. So I'll just say interface G0/0. It's G0/0/0. No shut. Wow, it is that interface that's up. You can see the links have turned to green now. So I need to give it an IP address. So let me say IP address 192.168.10.10. No, 10.1. Subnet mask is 255.255.255.0. And I say no shut. It's already up. I need to go to my PC here, right here, this laptop, go to the desktop and assign it some IP 192.168.10.2, for example. Same subnet mask. I must give it a default gateway, which is the same as the IP of the router, 192.168.10.1. That's the default gateway. We don't have to put a DNS server there. Now, so the first thing I need to do is to ping that PC if I can access it. So I can say ping 192.168. I'm pinging the router, by the way, .10.1. You can see I'm receiving replies here. I can, from the PC here, I can access the router. Remember, I'm not using the console cable, is only used for configuration. To send this internet traffic, it now uses the copper straight through. Now, I want to access, let me show you. I want to access from the computer. I want to access the command line of the router. So I'll say SSH-L So I want to access the command line of the router. So I say it's SSH-L. I put the username. I want to put the first username, which was called admin1. Okay. So we had given it privilege 15. So we want to see what is going to happen. So SSH-L, then you say admin1, put the username, admin1, and then put the IP address of the router, which was 192. 168.10.1. Okay. So let's see what happens. So when I press enter, it will ask me for the password of this user, which was admin1 per 55. So admin 1 per 55. You can't see the password when you're typing it. That's a security feature for the Cisco devices. So press enter, and you see clearly we are in the router. We have already logged into the router, and now we can do so many things. Can say show run, for example. You can see some of the details of the router here. You can see the details we had configured here. Admin1 per 55. Secret. Do you know we said admin1 per 55? Can you see it has been encrypted here? You can't even know that is the password. That is admin1. This is admin2 per 55. It's here. Okay. We use version 2 of SSH. The domain name is here. I continue pressing enter. I can see the IP address that are configured in the router. So many other things that we can see here. Transport input SSH. Sure. Now, one thing you realize, I don't know whether you notified it. Let me do it again. You can just exit and they'll get out of the router and back to the PC command prompt. Look at this. I want to log in again using admin1. Look at this. Look at this. I put his password, which is admin1 per 55. Look at where does it take me? It takes me straight to the privilege exec mode. And I want to say here conf t, and I need to say enable secret class. All right, for the privilege exec mode password. Now, let me exit again to go back to the PC. Exit again. Now, look at me. I want now to log in with the username number 2 for the user 2, admin 2. So I'm gonna leave the password, the IP address. I just change the username here from admin1 to admin2. And when I put enter, I need the password for admin2, which was, and you know the privilege for admin2 was privilege 0. Admin1 was privilege 15. When you put the password, it took us to the privilege exec mode where we didn't need to put the second password. For here, I can put admin2 per 55. Look at where we are taken. Because of privilege 0, it takes us to the user exec mode where we must put enable, enter, and then you must put a second password. And that password was Cisco. Is it Cisco? It's class, yeah. Okay. Then
Class.
I can, yes, class, correct. So you realize when I use a lower privilege, you are required to put in 2 passwords to get in. I must put the privilege exec mode password. When you give a higher privilege like 15, someone is not required to put the privilege exec mode password. They are taken straight to the privilege. So have you seen what is the effect of the privileges?
Yes, thank you.
Karibu, you're welcome. All right. So so this part is just telling about there are always the devices come with some services that are that need to be disabled because they are unused normally. So it's important always leave them disabled, and we will be talking about some of them soon. Things like the HTTP, because the routers come with a certain element of web server. So any services, any ports that are not being used, it's important they are disabled. Even ports that are not being used should remain disabled because the hackers can always take advantage of them so often. So that's the end of that particular chapter, and I want us to do now the very last